Oh, good day, everyone. My name is Giancarlo V. Hinojosa, and we are the Group 3 here to present and discuss the pressure vessels, screw fasteners and rivets, and the mechanical spring. So for the subtopic of the pressure vessel includes the introduction, the classification of pressure vessels, stresses in a thin cylindrical shell due to an internal pressure, circumferential or hook stress, longitudinal stress, change in dimensions of the thin cylindrical shell due to an internal pressure, thin spherical subjected to an internal pressure, change in dimensions of a cylindrical spherical due to an internal pressure, and thick cylindrical shells subjected to an internal pressure. So for the introduction, so pressure vessels are the containers for fluids under high pressure. So these are the application: petroleum refining, chemical, power, food beverages, and pharmaceutical. So sa mga hindi nakakaalam na ang a petroleum refining is a process uh, uh, wherein petroleum refineries transform crude oil into useful products such as yung petroleum gas, gasoline, petrol, kerosene, and more. So for the chemical and pharmaceutical, since yung ating pressure vessel is a container, it is designed to hold gases or liquids at a pressure substantially higher or lower than the ambient pressure. So yung ambient pressure natin is the pressure of the surrounding medium such as gas or liquid and is in contact with the object. So in power industry naman, since ang pressure vessels natin are widely used in various power generation facilities such as nuclear power plants, hydroelectric power plants, and thermal power plants. Then for our food industry, food and beverage industry, so it helps, yung pressure vessel natin helps the industry to process food in faster way and more food can be produced. So merong three types in general ang isang pressure vessel. First is a horizontal pressure vessels, vertical pressure vessels, and spherical pressure vessels. However, meron kasing mga special types ng vessels like the regeneration tower vessel and a reactor na they are named because of their specific use only. So for the first type of pressure vessel, horizontal vessels and drums are relatively large diameter cylindrical pressure vessels used for a variety of process functions. Their height above grade is usually determined by the NTSH requirements of the pumps in the liquid outlet line or the gravity flow requirements to other equipment. Horizontal siya. Tapos ito yung support system niya. For the vertical pressure level, this is a vessel that has an upright orientation design. They are fit with different types of support, such as skirt and leg, to hold the weight of the vessel. So, since itong vessel na to is vertical, it needs support. So, commonly, apat siya. Pero nakadepende siya sa diameter ng ating vessel and yung load niya. Ang makikita natin dito sa part na to, ang makikita natin dyan is yung skirt and ito yung leg. Leg na will support the vessel. They can also perfectly fit in small amount of ground spaces, pero as much as possible, pero kasi dapat mataas din yung ating space para sa kanya. Next is the spherical pressurized storage vessel. This type of vessel is preferred for storage of high-pressure liquids because yung sphere is a very strong structure, and advantage pa nito is yung even distribution ng stresses niya both internally and externally. Generally means that walang weak points sa ganitong pressure vessels. So, ang tall vertical tower is a sample of a type of vessel which is constructed in a wider range of shell diameter and height. Isa tong type ng isang vertical pressure vessel. They can be relatively small in diameter and very large. Example is yung 4 feet diameter and 200 feet tall distillation column. Next is they can be very large in diameter but moderately tall and moderately tall. Example is 3 feet in diameter and 150 feet tall tower. Internal trees are needed for flow distribution. So next is a vertical reactor, same as a vertical pressure vessel. Figure shows a typical reactor vessels with a cylindrical shell. The process fluid undergoes a chemical reaction inside a reactor. This reaction is normally facilitated by the presence of a catalyst, which is held in one or more catalyst vessels. So for the main components of pressure vessel, first is the shell. It is the primary component that contains the pressure. Shells are either cylindrical, spherical, and conical in shape. So balik tayo dito sa isang figure. So ito yung ating shell. Dito. Kumbaga siya yung pinaka-container ng ating pressure vessel. So for the head, all the pressure vessels must be closed at the ends by heads. Ito. Yan. Sa taas and sa baba. So heads are typically curved rather than flat kasi yung reason niya is yung curve niyang configuration are stronger and allow heads to be thinner. And lighter siya and less expensive sa mga flat na heads. Next is a nozzle. It is a cylindrical component that penetrates into the shell or head of a pressure vessel. Next is support, which is used to bear all the load of pressure vessel, earthquake, and wind loads, and is considered to be non-pressurized part of the vessel. Sinabi ko nga kanina, ito. For example, ito, spherical pressure storage vessel. Ito yung mga support niya. The next, ito yung type ng support na makikita natin sa mga pressure vessel. Una is the saddled support. Horizontal drums are typically supported at 2 locations by saddle support. So nakaganon kunwari, for example, ito yung ating drum or pressure vessel, both ends dito. Then it spreads over a large area of the shell to prevent an excessive local stress in the shell at support point. One saddle support is anchored, whereas the other is free to permit unstrained longitudinal thermal expansions of the drum. Next is a leg support. In small vertical drums are typically supported on legs that are welded to the lower point ng ating vessel. Dito. So, the number of legs depends on the drum size ng ating drum size and loads to be carried. So, pag mas mabigat and mas malaking diameter ng ating pressure vessel, automatically, mas maraming legs na kailangan to support it. And support legs are also used for spherical pressurized storage vessels. Next is the lug support. Vertical pressure vessels may also be supported by lugs. The use of lugs is typically limited to pressure vessels of small and medium diameter. For example, is yung diameter niya is only 1 to 10 feet. Then the lugs are typically bolted to horizontal structural members in order to provide stability against overturning loads. Next is the skirt support. Tall vertical cylindrical pressure vessels are typically supported by skirts. A support skirt is a cylindrical shell section that is welded either to the lower portion of the vessel shell or the bottom head. So lower portion, or yung bottom head ng ating pressure vessel. So the skirt is normally long enough to provide enough flexibility to the radial thermal expansion of the shell that will not cause high thermal stresses at its junction with the skirt. So material used for manufacturing pressure vessel. So first is the titanium. Bakit nga ba titanium? Kasi ang mga titanium is extremely resistant sa corrosion. Next is it requires a very little maintenance, and also it is a non-toxic in nature. Next is the nickel alloys, which provides excellent protection from the thermal expansion. It is also suitable for use in harsh environments and extremely reliable and capable of lasting for several years. Then the stainless steel, it is also extremely resistant to chemicals, has a high resistance to corrosion, and has the capability of withstanding humid conditions such as sunlight or high temperatures. Next is the carbon steel, which is an excellent material in tensile strength. It resists vibrations and shock and can be recycled easily. Last is the aluminum, which is capable of maintaining high tensile strength between 70 to 700 megapascal, and is easier and more effective, cost-effective to machine compared to stainless steel, and has a larger coefficient of expansion compared to other metals. So classification of pressure vessels. Number 1 is according to their dimension. The pressure vessels, according to their dimension, may be classified as thin or a thick shell. So if yung wall thickness ng ating shell is less than 1/10, it is called as a thin shell. Then if the wall thickness of the shell is greater than 1/10, yung ating shell is called a thick shell. So thin shells are used in boilers, tanks, and pipes. On the other hand, thick shells are used in high pressure cylinders, tanks, gun barrels, and etc. Next is according to their end construction. So the pressure vessels according to the end construction may be classified as open end or closed end. So imagine na lang natin na isang simple cylinder with a piston, and such a cylinder of a press is an example of an open-end vessel. Bakit? In case of a vessel having an open ends, yung circumferential or hoop stresses niya are induced gamit yung fluid pressure. So in the other hand, ang isang example naman ng closed-end vessel is a tank. In case of closed ends, longitudinal stresses, in addition to circumferential stresses, are induced also. Next is they can be classified based on the purpose of the pressure vessels. For example, is if the pressure vessel is used primarily to store fluids under pressure, for example, is a storage tank, this is what we call a storage vessels. So if the vessel in which various processes are performed, such as breaking down a product, combining a product, removing various elements or aspects of a product, and more, this is what we call a process vessels. For example, is an separator, drums, reactors, distillation tower, and more. Isa pa is heat exchangers. So heat exchangers are used to transmit heat between two or more fluids, and they are commonly used in the food, pharmaceutical, energy, and bioprocessing industries. Next is the boilers, which are heat transfer equipment that utilize fuel, nuclear, or electrical power as sources of heat. They are typically composed of an enclosed vessel that allows heat transfer from the source to the fluid, and they are primarily used to heat liquids. So vessels typically corresponds to either the vertical or horizontal variety, although some spherical storage vessels are also used. Then another one is the fired or unfired pressure vessel classification. So if a pressure vessel uses an external heat source, direct man shower, indirect, to maintain a liquid or gas at high pressure, this is what we call a fired pressure vessel. Next is if yung type of vessel, pressure vessel natin, does not expose to combustion or burning of fire, this is what we call the unfired pressure vessel. So for the stresses in a thin cylindrical shell due to an internal pressure, the analysis of stress induced in a thin cylindrical shell are made on the following assumption. First, yung effect ng curvature of the cylinder wall is neglected. Second, the tensile stress are uniformly distributed over the sections of the walls. 3 is the effect of the restraining action of the heads at the end of the pressure vessel is neglected also. So makikita natin sa figure 7.1 yung failure of a cylindrical shell. First is the failure of cylindrical shell along the longitudinal section, and next is the failure of a cylindrical shell along the transverse section ng ating pressure vessel. So next is the circumferential or hoop stress. Consider na lang natin na a thin cylindrical shell subjected to an internal pressure na makikita natin dito sa figure 7.2. A tensile stress acting in a direction tangential to the circumference is called the circumferential or hoop stress. In other words, it is the tensile stress on longitudinal section. So, for the 7.2 figure, letter A, makikita natin yung longitudinal section niya. Then, ito yung cross-section of shell natin. Dito makikita yan. So, the following points may be noted. In the design of engine cylinders, a value of 6 mm to 12 mm is added in the equation to permit rebarring after wear has taken place. Therefore, yung wall thickness natin is equals to the internal pressure times the diameter times the over 2, since circumferential to, times the circumferential stress plus 6 to 12 millimeters. And in constructing large pressure vessels like steam boilers, riveted joints or welded joints are used in joining together the ends of steel plates. In case of riveted joints, the wall thickness of the cylinder is equals to the internal pressure times the diameter over 2 times the circumferential stress times the efficiency of the longitudinal riveted joint. So for the circumferential or hoop stress, the following points may be noted. In case of cylinders of ductile material, the value of circumferential stress may be taken 0.8 times the yield point stress. And for brittle materials, it may be taken as 0.125 times the ultimate tensile stress. So in designing steam boilers, yung wall thickness niya is calculated by the previous equation natin and is compared with the minimum plate thickness as provided dito sa table na to. So for the minimum plate thickness for steam boilers, if yung boiler diameter natin is 0.9 meters or less, the plate thickness of our pressure vessel should be 6 millimeters. For the 0.9 meters and up to 1.35 meters na boiler diameter, ang minimum plate thickness natin should be 7.5 millimeters. And above 1.35 meters and up to 1.8 meters, the minimum plate thickness should be 9 millimeters. Then if it is over 1.8 meters, the minimum plate thickness should be 12 millimeters. If the calculated value of T is less than the code requirement, then the latter should be taken, otherwise the calculated value may be used. And for the circumferential or hoop stress again, the boiler code also provides that the factor of safety shall be at least 5, and the steel of the plates and rivets shall have a minimum of the following ultimate stress. So for the tensile stress, it should be 385 megapascal, compressive stress 665 megapascal, and for shear stress 308 megapascal.